Okay, so today is day 2 of area between curves. So again, I've put the two equations here. This is the area if you're doing vertical strips, okay, when your two functions area intersect and you draw strips perpendicular to the x-axis, and this one is for horizontal perpendicular to the y-axis, okay? So today's example, I really want to go over what happens if you don't want to sketch the curves. How do you find your information, okay? So this problem here, it's in terms of x, so most likely I know I'm going to be using this equation from a to b, the function on top minus the function on bottom dx, okay? So first and foremost, I need to find my points of intersection. So I need to know where these two graphs intersect. Well, looking at their equations, I know both of them are at 0, 3. Because you plug 0 into both of them, you have 3, because I can see this here. But if you remember from Algebra 2 and Pre-Cal, the way to find where two functions intersect is to set them equal to each other. So we can set them equal to each other. And we move everything onto that side. So we get 2x squared minus 6x equals 0. Factor out our 2x, so we get x minus 3. So our solutions, or our points of intersection, are 3 and 0, okay? Which means our area starts here and ends here, okay? So when I go to do my integration, I know this starts at 0 and goes to 3. Now, knowing that this is the quadratic and it opens up, so let's say the red one is g of x, it's going to look something like this, okay? And this one here is going to open down because it has a negative lead coefficient, so it's going to look something like that. And they're going to intersect here and here, like we said. So from that, I know that this, my vertical strip, the negative one is my top function, or the positive one is my bottom. Another way to do that is you could plug in any point in between 0 and 3. For instance, if I plug in, let's start with g. So if I plug in g of 1, any number between my limit 0 to 3, because those are my points of intersection. When I plug in 1, you get 1 minus 4 plus 3, which is 0. And then f at 1, which gives you negative 1 plus 2 plus 3, which is 4. So which one has a higher y value? This one, which means this one is your top function, and that one is your bottom function. Okay? And at this point, you just plug them in. So my top function is negative x squared plus 2x plus 3 minus my top function, which is x squared minus 4x plus 3 dx. So there's my integral, okay? And at this point, we're just evaluating a definite integral now. So let's simplify this. So 0 to 3, and this distributes in, so I get negative 2x squared plus 6x dx, okay? So make sure you distribute the negative into each term as you add them all up, okay? Now it's super simple integration, okay? So add 1 to the power, divide by the new power, so you get negative 2/3 x cubed plus, that's going to be 3x squared from 0 to 3, okay? So we plug in 3, so we get negative 2/3, and this ends up being 3 cubed plus 3 times 3 squared minus, and when you plug in 0, you get 0. And then 3 cubed is 27, divided by 3 is 9, so this is negative 18. Today's code is G0 T U G 0, 0, D. And that is your code for today. And then lastly, you've got 3 squared is 9 times 3, which is 27, and negative 18 plus 27 is 9. And so that is your area between the two curves. Okay, that's it. So when we're doing these integrals, basically we're just doing a definite integral that we have to set up with one of these two functions. So if you know how to do a definite integral, you know how to do this once you get to this point here. Once you've got it all set up, we're just back to doing definite integrals. Okay? The hardest part is just figuring out the points of intersection and which function's on top and which one's on bottom.